What is payback in energy projects? Payback period is the time it takes for an investment to generate enough savings to recover the initial cost of the investment. The formula for payback period is initial investment over annual savings. Importance helps determine how quickly an investment will start generating returns. Example, initial investment $5,000, annual savings $2,500. Payback period is simply initial investment over annual savings, which is 2 years. Understanding VFD, variable frequency drive. A VFD is a device that controls the speed of an electric motor by varying the frequency and voltage of its power supply. VFDs help save energy by allowing motors to run at speeds needed for the application rather than at full speed all the time. Analogy: imagine a chef in a restaurant kitchen who can adjust the heat of the stove based on the cooking needs, rather than keeping it at maximum heat all the time. This adjustment saves gas and ensures food is cooked just right. Example of VFD in a restaurant. Scenario: a restaurant uses a VFD to control the exhaust fan in the kitchen. Before VFD, the exhaust fan runs at full speed all the time, consuming a lot of energy. After VFD, the exhaust fan speed is adjusted based on the cooking activity, reducing energy consumption. Benefits: energy savings, reduces energy use by 30 to 50%, extended equipment life, less wear and tear on motors, improved comfort, better control of ventilation. Analogy: adjusting stove heat. Just like adjusting the stove heat saves gas, using a VFD to control fan speed saves electricity. Payback calculation for VFD in a restaurant. Initial investment, cost of installing VFD on exhaust fan is $2,000. Annual savings reduced electricity bills $800 per year. Payback period is VFD cost over savings, which is 2.5 years. Next, I will demonstrate how to calculate payback for a VFD project using Excel. So I want to show you how to calculate the payback, but before that, I want you to download this PDF file, VFD Energy Savings. So let me first introduce you to the file. So let's say you are buying VFD from a vendor, and the vendor sends you this file. And here's a description of how the VFD works. VFD save energy by controlling the speed of motors to match the actual demand. When a motor runs at lower speeds, it uses less energy. VFDs help reduce energy consumption, lower electricity bills, and extend the life of the equipment. And for your branches, these are the potential VFD savings and the estimated project cost. So I want to download this data or import this data in my Excel file. So how to import this data in my Excel file? This is how you do it. First, open an Excel worksheet. Go to a blank workbook. And then go to data, get data from file. What kind of file is it? It's a PDF file, right? From PDF file. And then navigate to your folder. For mine, it's in desktop, VFD Energy Savings. Once you do that, it's connecting. Once you do that, it will show you the different tables in the PDF file. For us, the applicable table is the first one, load. Easy, right? So once you load the data, I'll just get some space here to make it look nicer. So here the VFD savings in kilowatt hour and the project cost in dollar. So I want to calculate the payback. But before calculating payback, remember, the payback is what? The project cost in dollar divided by the savings in dollars. We don't have it in dollars, we have it in kilowatt hours. So we need to first calculate the savings in dollars. So let's say, although it's going to vary from city to city, so let's say for now, to make it easier, charge is in dollar per kilowatt hour, it is 20 cents. Although that is going to vary from city to city, but for now, for ease of our calculation, we'll just consider that. So simply because it's in dollar per kilowatt hour, 20 cents per kilowatt hour. So that one and absolute reference it because we want to keep the chart same this time times VFD savings in kilowatt hour. Dollar per kilowatt hour times kilowatt hour gives you the savings in dollars. Once you get that, you can calculate the payback easily. I'll just format it because it's a smart table, so that's okay. So payback equal to project cost in dollars divided by savings in dollars, and that's the payback 16.67. You can just go to home and set it to 2 decimal places, and you can align it to the middle. That's how you can calculate the payback. Now, let's say the dollar per kilowatt hour charge is different for different cities. So I'll make up some values from 10 cents to 20 cents. So let's say for this city, it's or I can also use the rand. I'll just generate some random values, see if it let's see if it works. Rand between, that's how we do it. The smallest value can be 10 cents and the largest value can be 20 cents. Although, I mean, it depends from city to city. I'm just generating these values as part of the example. So it's not really okay. Let's just pretend that these are the charges. I know it's kind of high, but I mean, just I'm demonstrating you how to do it in Excel if you have variable charges. I mean, I can type from 10 cents to 20 cents, but that will take a long time. So I'll just generate some values. So the savings in dollars. Actually, I don't hold. Yeah, the savings in dollars is the VFD savings in kilowatt hour times the dollar per kilowatt hour. So actually, see, since it's a random variable, it's just changing it from time to time. So let me just copy it and paste it as value so that it doesn't happen anymore. So if you click on the formula, says VFD savings in kilowatt hour times dollar per kilowatt hour, which is the savings in dollars. Again, just set it to the decimal places. So this charge now varies with the city. What if you want to calculate the overall payback period? Okay, first let me calculate the payback period for each city. That is not done yet because one final step is project cost in dollars divided by savings in dollars. And to make it the same color, just go to Format Painter, select this cell, go to Format Painter, and then select this. So we have the paybacks now for different cities because it has different charges. So different charges will apply for different cities, and we have different paybacks now. What if you want to calculate an overall payback? How to calculate an overall payback? So first of all, overall payback is really the total project cost divided by the total savings, both in dollars, of course. So one way to do it is that just sum of the total savings, sum of the total project cost and divide them. So let's do it. I'll show you different ways. Okay. So sum of total project cost, sum of total savings. $7.42 years. Okay. That is the overall payback period for the portfolio. Let's try to calculate that in a different way. So let's put some space here. Calculate that in a different way. So see here, instead of doing it row by row, let's say kilowatt hour times $0.42 per kilowatt hour is this much savings. I can just do the sum product of this array and this array. That will give me the total savings. You want to see how? So let's check. So total savings here is $6,688. And I can get the same savings in a different way. So equal to sum product of the first array is this one, and the second array is dollar per kilowatt. See, it's basically the same value. So the reason it works like this is because when you do the sum product, it's actually doing this. 1500 times 0.42 plus 1200 times 0.60 plus 1800 times 0.21 plus 1600 times 0.81 plus 1400 times 0.64 and so on. So this sum product will do everything together. So how about we use the sum product formula here for the total savings? So first of all, the sum of the project cost is this array divided by sum product array 1, comma, array 2. So you see here, because I didn't put the bracket, ending bracket, so it will automatically put the ending bracket for me, and its overall payback is 7.50. That's how you use the sum product formula. So we can calculate. So first of all, we calculate the payback for different branches using the same rate. Second, we use different rates for different cities. So we have a different payback here if you compare it to the first one. Next, we calculate overall payback by doing the total savings, by doing the total project cost over total savings. And an alternative approach is to do total project cost divided by the sum product of savings for the branches. And that's the first array. And the second array is going to be the dollar per kilowatt for each branch. So these are different alternative ways to calculate the same overall payback.